Today we're looking again at trigonometry, specifically a section where we solve triangles, and that means finding missing sides and missing angles of a triangle, and basically that's what we call solving triangles. But for now, we want to look at solving or finding missing sides. Okay, how to find a missing side in a triangle? Well, let's look at an example. It says in the following diagram, find the length of AC and then find also the length of BC. And you're going to be very observant in terms of your diagram, what you're given and what you're looking for. And in combination with what you're looking at, remember your definitions, because those are useful in helping you set up an equation that you end up having to solve for the unknown that you're looking for. For instance, if we look at number 1, we're looking for AC. But when we look at AC is opposite the angle we given. Now you remember this is always with reference to the angles that you've got in your triangle. So opposite 40 degrees, there's the side AC that we're looking at. We've also been given the hypotenuse of our diagram, and that means you then need to set up an equation that will assist you in actually getting that. So let's set up an equation. We know of our definitions that opposite of hypotenuse, that's the definition for sine. So the correct trig function to use, there would have been sine. So sine 40 degrees equals the opposite side over the hypotenuse, and that opposite side is AC, and the hypotenuse is 20 units. Perfect. There's our equation. And apply your knowledge of equations. How would you get to AC? Obviously multiply both sides by 20. And in the end, we're left with AC is equal to 20 sine 40 degrees. That's what you'll punch in your calculator, and then you easily get your answer. So pretty easy, straightforward stuff. But remember your definitions, because they help you to set up the kind of calculation you will need at the end. Let's look at number 2. It says the length of BC. Now BC is adjacent to that angle 40 degrees. And remember again, we've got the hypotenuse, but you also have AC that you've just found out. But I've always advised that in order to be safe, always use what you've been given, so that in case your answer was maybe inaccurate or wrong in the previous calculation, you're still safe in that you're using something that was given. So that definitely takes us to cos, because the trig function that has, or trig ratio that has the ratio of adjacent over hypotenuse is cos. So cos 40 will be adjacent over hypotenuse. Adjacent is BC that we're looking for. Hypotenuse is 20. Again, multiplying both sides by 20 will give us 20 cos 40. Punch your calculator, and out comes your answer, and you're done. Pretty easy, straightforward. Let's look again at another scenario, and here we're given a diagram, and we asked to find the length of PQ and the length of PR. We're given the angle P as 62 degrees and the length of QR as 15. And remember, when you're using your trig functions or trig ratios, you just need two things in order to get what you're looking for. And in this case, an angle and another side is good enough to help us find a missing side. Okay, so let's have a look at finding PQ. Based on the diagram, PQ is adjacent to angle 62 degrees. It's next to angle 62 degrees. It's adjacent. And then we're also given QR, which is 15 units, and it's opposite angle 62 there. Okay, so you want to be observant of such things. Those help you to determine what trig function to use. And the trig function that will get us there is 10. 10 62 is opposite over adjacent. And therefore we can just plug in what we've got. PQ is what we're looking for, which is adjacent, but QR is 15. And multiplying both sides by PQ, you remember we're trying to get PQ, so we want PQ to be a numerator there, or a subject of the formula. So multiply both sides by PQ, then divide both sides by 1062. And what that does eventually is basically to swap your PQ and your 1062. So PQ goes there, and then 1062, sorry, PQ goes there, and then 1062 goes there in the next step. And then in the end, you're just left with a calculator. Punch your calculator, and you'll get 7.98. So pretty easy. A lot of errors that learners make in this step, where they think that everything is just going to be multiplied both sides by 15, but you can't do that. 15 is a numerator, and we want to get to PQ. So we have to multiply both sides by PQ, and then divide both sides by 1062. That's why in the end we end up with this outcome. So always be on the lookout there. If PQ was the numerator and 15 was the denominator, now that's different. We would need to multiply both sides by 15. So just be on the lookout there of how you need to manipulate your equation in order to get what you're looking for. And these are skills of basic equations that you need to know in terms of fractions. Well, our diagram now looks like this. It means that we've got the length of PQ. The next question is asking us to find PR. Well, looking at the diagram right now, we don't even have to use trigonometry because now we are in a right angle triangle with two sides. That means, hey, we can apply Pythagoras. But when you do that, remember to give us a reason. And the rest is just simple calculations. Find the square roots of both sides. Try and punch everything as is so that you get an accurate answer in terms of decimals. And then you get your answer there with ease. Okay, of course there's nothing stopping you from using trigonometry, but really why would you go there if you already have a very easy method that will take there quicker. You don't even have to show us this step. It's just that I'm trying to illustrate what you need to do. Okay, that's it.